To introduce this lab, we're going to begin by discussing the theory behind it. Ionization is the process of gaining or losing electrons, resulting in a change of charge on the atom. Strong acids, when dissolved in water, will ionize completely, while in comparison, weak acids will only ionize slightly. In this lab, the ionization of acetic acid will be measured through the brightness of the light bulb. To further explain, the more ionized the acid, the brighter the bulb will be. To increase percent ionization, the student must dilute the solution with distilled or deionized water. The reason that the percent ionization increases as the solution is diluted will be explored in this lab and further explained at the end of this video. In reference to acetic acid, a 10 molar sample of the acid will have a 0.132% ionization, while a 0.1 molar sample of acetic acid, meaning that there was an increase in volume because the solution was diluted, will have a 1.32% ionization. This shows that the more dilute the acidic solution is, the greater the increase in percent ionization will be. In this lab, acetic acid is used. Acetic acid is harmful to the skin and tissues and is moderately toxic by ingestion and inhalation. With this in mind, it is suggested that you wear protective chemical splash goggles, a chemical-resistant apron, and chemical-resistant gloves. The materials used in this lab are 100 milliliters of acetic acid, 90 milliliters of distilled water, a 250 milliliter beaker, 2 rods of solid copper, a 9-volt battery, a light bulb, electrodes with both a positive and a negative lead, and a plastic cup. In this lab, first you will add 100 milliliters of acetic acid to the plastic cup or a 250 milliliter beaker. Second, you will lower the conductivity apparatus, which consists of the 9-volt battery, the light bulb, the electrodes, and the copper rods, and immerse its electrodes into the acid. Then, you will add distilled or deionized water to the beaker in approximately 30 milliliter portions and observe the change in the brightness of the bulb. Repeat this as many times as desired, although we suggest repeating around 3 to 5 times to get the best results.
As you dilute a solution, the molar concentration of the weak acid will lower as well. If the molar concentrations decrease, then Q will become less than K. Therefore, equilibrium will shift towards the products, which in return will increase percent ionization of the weak acid. If there is an increase in percent ionization, the acid will produce more ions. Pertaining to this lab, the more dilute the weak acid, the better it conducts, meaning the brighter the light bulb will glow. Essentially, the more ions released, the brighter the light bulb. In this lab, we use acetic acid as opposed to hydrofluoric acid. This is due to hydrofluoric acid being extremely toxic and having the ability to leave painful burns on the skin. Therefore, it was much safer to use acetic acid. In the 2018 AP Chemistry exam free response, many students blinked out when a particular question about percent ionization had appeared. Before I explain the correct answer to the 2018 AP Chemistry exam free response, question 5, part C, feel free to pause the video now to try to solve it on your own. This lab should clarify questions concerning the free response question 5, part C, concerning the ionization of hydrofluoric acid. The question asked the student to predict whether the percent ionization of a weak acid will increase, decrease, or remain the same when adding distilled water. To further clarify, this is just a confusing way to say that the solution is being diluted. In this lab, you found that as you added more water, also known as diluting a solution, into the acetic acid, which is a weak acid, the brighter the light bulb grew. The brighter the light bulb, the more ions were produced, meaning an increase in percent ionization. Therefore, the answer for this response should have been an increase in percent ionization. As the acidic solution is diluted, there is a decrease in molar concentration. If the student were to create a Q expression using the decreased molar concentrations, then Q will become less than K. Therefore, equilibrium will be shifted towards the products, overall increasing percent ionization. Now that we have finished presenting this lab and the importance of it, take a look down at the description to try out some acid and base NIMSY problems.